Hi, I'm Lakshmi Narayan-Ashok, VP of Technology at GDIT. Mission Partner Environments, MPEs, for short, have traditionally enabled joint operations and secure information exchange for our allied nations, mission partners, and our joint forces. However, MPEs are evolving, and innovative technologies have a huge role to play in this evolution. Joining us today are Eric, Jason, and Brandon to talk about this critical topic. Eric, want to introduce yourself?
Hi, I'm Eric Tapp, Mission Partner Environment Lead here at GDIT.
Hi, I'm Jason Devine, Solutions Senior Director. I'm responsible for cloud capabilities for our divisional CTO.
Hi, I'm Brandon Bean, and I am the Senior Director for Artificial Intelligence and Machine Learning and the lead for Luna AI at GDIT.
Thank you, folks. Eric, let me ask you the first question. So what are your thoughts on how MPE is evolving today from joint operations into a warfighting network? It would be great if you could give us an example of how the shift is happening.
Yeah, absolutely. Thanks, Lakshmi. So it kind of helps to understand where they're at now, where they started, and where they need to go. So mission partner environments have historically been used for information sharing between the United States and foreign mission partners on a bilateral or multilateral secret releasable level. And this has, the architecture has kind of evolved to a significant number of single use networks and environments that are stovepiped. Data is not very transferable across those. Mm-hmm. And so what you have is a very static environment that's really only fit for a single mission, and then you kind of have to rebuild. Where we need to go, we need the mission partner environment to be dynamic. It needs to evolve as the mission evolves. It needs to change as the mission partner set changes. And we need it to be usable across multiple mission sets and multiple theaters. So it needs to create some efficiencies. We need to extend those capabilities to the edge. And most importantly, we need to evolve them to the point where the warfighters can take the data that they are generating and essentially weaponize it to enhance their ability to make decisions, to make those decisions faster, because in the modern battlefield, everything is happening much faster across a significant and vast expanse of space. So speed is of the utmost. And so I think that as we look at these technologies today, we're going to see why they're critical for advancing those warfighter capabilities in those areas.
All right. How about the example?
So kind of a historical example would be the Afghan mission network. Afghanistan kicked off in 2001. We built the network and just slowly built it up over time. That met the need for that particular mission set, but as Afghanistan ramped down, almost 2 decades later, all that capability and capacity was lost because it was not something that could be repurposed outside of the Afghan theater. And so what you have in contrast today are things like the data-centric environments that CENTCOM and INDOPACOM have built, CPE and IMN. These are data-centric, they're flattened, they're a SecRel environment to allow for multiple release abilities across bilateral and multilateral exchanges to take place. They're dynamic, and they can be repurposed for any mission requirements that the theater commander may have.
Okay, thanks for that. So let's talk a little bit about technology now. Jason, when I think innovative technologies, of course, cloud, AI, zero trust, and cyber comes to mind. But what have we advanced in cloud to support something like an MPE today?
Sure. Cloud capabilities are an enabler for us. They allow us to respond to the specific demand signals that Eric has referred to, the capabilities that are desirable under this evolving mission, and they allow us to deliver those solutions more quickly. The hyperscale CSPs have evolved their service portfolios, and I want to recognize some of the work done by the Defense Information Systems Agency, DISA, through the Joint Warfighter Cloud Capability Contract to compel the hyperscale cloud service providers to expand their portfolios to offer a richer set of deployable capabilities. And so the CSPs have responded in this area in really 2 key ways. So first, they've expanded the number and the variability of footprints that we're able to deploy. So we can obtain platforms of differing levels of size, capability, and push those to the edge. And those platforms come with authorized cloud services, cloud native services, that allow us to do a lot of the engineering that's necessary to automate configuration and deployment, some of the things that Eric referred to specifically about repeatability. So building these solutions as layered on top of cloud services is a multiplier for us in terms of efficiencies as we move forward. The second thing they do for us is the CSPs have responded by opening up their terrestrial and orbital networks to enable a greater flexibility from a connectivity perspective at the edge. So combined, these capabilities authorized by the department allow us to build solutions that can get to ATO more quickly and to deliver those solutions on a repeatable basis.
Yeah, I was going to ask you about how this operates in a denied, disrupted, intermittent, and limited bandwidth DDoS environment, especially as I feel most of the war fighting is done in such environments. And so what have the cloud providers and network providers done there?
This is an interesting area because it is in many ways unnatural for cloud services to deploy to disconnected environments. And disconnected state is not the desired state. So the challenge is, how do you offer service and capabilities at the edge that take advantage of connectivity when it's available, but continue to function and operate when that connectivity is lost? So this is really a multifaceted problem that is addressed first with the cloud services capabilities that are increasingly offered disconnected options. So the deployable platforms themselves are more capable, and this capability is evolving to provide advanced capabilities when they are connected or not connected. And second, and really the primary burden, is on the application architecture and developers. And so Brandon, I know, is going to talk about the data fabric and the necessity of having the right data deployed to the right environments in case a disconnected state arises. And the application developers, so that those applications are aware of the state of the network and can operate appropriately so that they can offer more capability when they're fully connected, and then back that capability off as they become intermittent or completely disconnected, but always providing a minimum level of capability to meet the mission needs.
Thanks, Jason. So Brandon, you know, one of the things I said is we need to have quick decision made. And so what are some of the technologies that AI brings that helps and furthers the mission in an MPE?
Yeah, absolutely. So one of the great things about AI is it breaks down mission barriers. Eric talked about flattening the network. Jason talked about, you know, working in DDoS environments. And one of the major benefits of AI is being able to shift left that decision space. We're able to do more with more information in a shorter amount of time and allow warfighters to stay in the gray area, which is what we train them to do. One of the big things is when we look at the semantic layer of data, right? Jason touched on data fabrics and data mesh. How do we get data, one, off of the objective at the edge in a DDoS environment, but then be able to leverage that in the cloud? AI is a great enabler there because it allows us, one, to automatically tag that data and enrich it. And it also allows us to dynamically determine classification. So when we get into these bilat and multilat agreements, AI is an enabler that assists us in being able to rapidly share that data and limit the human interaction. So we get faster data sharing as well as extended data that goes out to the mission partner. One example I like to use of that and a good use case would be naval firing missions, right? How do we get target-enriched data, strip off TTPs that allow us to share it to mission partners who may be in a better position to be able to fire on a target than we are? And today we can't do that because of the abundance of critical data that is tied to that targeting mission and the target-rich data. And so being able to use AI to help scrub that in real time allows us not only to share the data more efficiently, but also work faster to flatten that network and work laterally across it. Another use of AI as a mission enabler is COA development, right? So being able to generate courses of action on the fly. Today we do that from the seat of our pants and experience and muscle memory. Having AI there allows that operator, again, to stay in that critical gray area, but providing them only the information necessary to help them make those critical decisions much faster.
I think that's a great example. Do you feel that the technology vendors are keeping up with getting us the right compute necessary at the edge to enable some of this AI?
I believe so. We're starting to see that both from the CSPs, right, who are designing edge-capable solutions that are powered, whether it is a distributed capability with compute and cloud services to support that, which gives you a comparable capability that you get when you're in a pure cloud platform. The other side of it is small form factor compute manufacturers are really starting to put more GPU-enabled capabilities on the devices. We're starting to see much smaller GPUs, and if you've seen the news recently, NVIDIA had released the Grace Blackwell platforms, which are going to revolutionize what we can do at the edge. And I think, as we see the dynamic shift, we'll see more of those platforms push toward edge-capable platforms with high-scale compute.
Great, thank you. So Eric, we heard from Jason and Brandon about some of the technologies involved. How does that tie into a few things you mentioned earlier, like data centricity and zero trust in an MPE?
So cloud and AI are going to greatly enhance the groundwork that has already been laid through the implementation of zero trust. Zero trust has allowed us to leverage user identity attributes and data tagging to clearly define who has access to what data and when. When you overlay cloud and AI on top of that, what you have is a greatly expanded, resilient network that allows us to dynamically control those capabilities all the way to the edge. It also allows us to leverage the AI component to do a couple things, not just operationally focused tasks, but also I think it will significantly impact the way that users who are creating data and owning data become comfortable with writing for release. That's a concept of everything that we create needs to be at some releasable level. And that's going to be hugely important for enabling the coalition in a warfighting aspect. The more significant data that we can release to our partners, the more they can be involved in a more significant manner throughout whatever crisis or mission set that they are participating in. And so what the operational impacts of these two technologies really become significantly enhanced resiliency, even out to the edge. And with the implementation of AI inside of the MPE space, you're going to see a greatly enhanced ability for the warfighter to sense and make sense not only of the data, but also the operational environment as well.
Wow, it's very interesting. So let me dig a little deeper into cloud. We talked about the evolution of MPE from a giant operations into more of a war-fighting environment. What next for cloud? How can it help in the evolution?
Sure. So the key characteristic of this evolution is flexibility. So no two MPEs are the same. No two mission sets of requirements are the same. So our interest as an integrator that's pulling solutions together to deliver for mission effect is speed. We need to be able to do these things quickly. So the authorized platforms and services from our CSP partners are a huge enabler because we can start the engineering process on top of that platform that covers roughly 50% of the challenge compared to building something from scratch. So traditionally, we've had to start with commodity hardware, commodity software, and then write the platform layer from scratch, and then take that through the authorization process, start to finish. This could take a year. During a recent exercise in the Indo-Pacific, working with one of our CSP partners and their edge platform that carries an authorization, a provisional authorization, we were able to add mission-relevant collaboration capabilities and AI at the edge. So this included language translation, image processing, and thread summarization for their chats. We were able to bring that into the environment and get the authorization to connect it to production networks in just 2 days because of the presence of the existing authorizations.
That's pretty impressive.
It very. So being able to take something like that into an environment, deliver capability quickly, and then just as important is the ability to replicate that capability. So what the CSPs give us is a reliable foundation upon which we can engineer solutions. And so we can spend more of our energy ensuring that those solutions meet the needs of the specific use case without having to cycle through this repetitive, foundational development effort. So it's a very substantial enabler for us, and it gives us, from an operations perspective, unburdens us considerably because we get a great deal of support.
And you get to move faster. The technology's advancements get you to accelerate that much faster.
They do, and the speed benefits have a cost benefit because the time it takes to do all those things over and over again has an inherent cost.
Yeah.
So by focusing on reuse and not just the stability and reliability we get from the service platform, but also the consistency of cost. So as we're planning these solutions, we have a pretty good idea of what it's going to cost, while simultaneously retaining that flexibility to meet the needs of a specific MPE use case. And then on top of that, I really see Brandon and the data AI teams as my customer, and my job is to provide them that secure, repeatable platform that gives them the basic compute, storage, and network capabilities that they need for their applications to work.
Yeah. Similar question for you, Brandon. So what next do you see in AI to help with the evolution of MPE?
So I think one thing that we will start to see, and I know it's one thing that we're presently working on, is AI-enabled policy decision points, right, or policy enforcement points to mandate, data sharing at the attribute-based level, right? So as we bring mission partners on, how do we quickly onboard them and then single-threadedly be able to share data without virtualizing the data, bloating the infrastructure and taking on additional tech debt to be able to do that? I think that's one area that we're going to see it, but the other one is dynamic classification of information. So today, one of the biggest challenges is no two SCGs, security classification guides, are alike. Every organization will classify the same data a little differently based on mission and other parameters. How do we take all of that data, right, and synthesize that in a way that we can allow AI to quickly be able to go over that data and identify what something should be classified, or in the lack of portion markings or classification, right, ensure that we're able to dynamically share that data and move it both up and down through security guards to be able to share dynamically. That's another big enabler, I think, really, that AI is going to bring. Yeah, and it'll be a tough nut to crack. Yeah. Then the third one is really synthesizing a lot of the sensor data that we're bringing in, right? How do we enable AI to dynamically fuse sensor data and generate COAs and other artifacts off of that data to allow quicker targeting and deployment of effects, right? So whether it's a counter UAS environment or a tactical high altitude air defense environment, right? How do we reduce the number of button clicks that it takes for a warfighter to be able to launch an effect and affect a decision on the other end of the spectrum, right? Whether offensively or defensively.
I cannot wait to see some of the pilots you put together on this. So last question for all of you. What excites you the most about this evolution of MPE? Eric, you want to take it first?
It's really exciting to see what GDIT is going to be able to do with regard to enhancing mission partner environment capabilities, taking it from information sharing to warfighting, taking it from enterprise to the edge, and overlaying those enhanced operational capabilities for the warfighter to, again, sense and make sense of their environment, make those decisions rapidly, and make better decisions. It's an exciting time to be a part of the mission partner interoperability space, and I think we're doing a lot to advance the cause for the warfighter.
I agree. Jason?
Lakshmi, I'm excited about the upcoming expansion of service offerings from our CSP partners. As I've stated, these are enablers for our solutions, and we're seeing an increased variety of offerings, and we're seeing an increased maturity in terms of both sophistication of the services, but also in terms of ease of use. Also, we're seeing evolutions on the networking side. Amazon Web Services is in the process of launching their Kuiper low Earth orbit satellite network that will offer another high bandwidth, globally accessible network so that hopefully we can minimize those instances of being fully disconnected. But ultimately, I'm excited about the opportunity of providing the application developers and the users of the system a powerful platform upon which they can develop capabilities without having to worry about all the details that's going on below their waterline.
Nice.
Yeah, I would really have to say, to play on what both Eric and Jason brought up. So faster development, faster integration, but for me it's about federated capabilities, right? How do we get to a true vision of CJAD C2 where it's one network, one unified capability, fully federated, and that's both at the data level, the model level, right? So we don't have to keep recreating networks, we don't have to keep recreating AI models, we don't have to keep recreating and virtualizing data, right? We get to true fabrics that create fully federated mission partner capabilities to both quickly onboard those mission partners, but then truly integrate what they bring to the fight to be able to create a cohesive operating environment for all warfighters.
Great messages to close out the conversation. Thank you very much, gentlemen, for your insights today on these topics. If you need further information, please feel free to visit our website, gdit.com/perspectives. Thank you.